Okay, we have one last thing in this section of the unit before our test. And this one last thing is actually just theory. And it's something that's called a galvanometer. Galvano and then meter. Okay? And a galvanometer is a device that's used to measure really small currents. Okay? So really tiny currents. We actually find galvanometers inside voltmeters and ammeters. And I think in our review, our preview of electricity, I talked about a voltmeter and an ammeter, I think. A voltmeter is simply a meter that's used to measure the voltage of a device. An ammeter is simply a meter used to measure the current in a device. And so now I'm just going back to do a little review here. So if I have a circuit with several resistors in it, and I want to measure the current flowing through these resistors, well, the current that leaves the battery is going to be the same current that flows through this resistor, and this resistor. Current in, this is called a series circuit, if you remember. And currents in series circuits equal each other. So I1 equals I2 equals I3 equals the I total, actually, that's leaving the power supply. So if I want to measure the current in this circuit, I would need to take my ammeter and put it in series with them because all the I's are equal. Okay? And my other option would be to put it in parallel. But if I put it in parallel, if I make a branch and put it up here, then when this current got to this spot, some of it would have to split and go through R1, and some of it would have to go up here through this ammeter. And so really what the ammeter would be reading would be the current not flowing through R1, and we don't want that. So ammeters always have to go in series, but voltmeters always go in parallel. So this is called parallel. In a parallel circuit, the I's don't equal, but the voltages do. So in a parallel circuit, my resistor is here, and I have another one here, and another one here. So R1, R2, and R3. And remember, when an electron leaves a battery and flows, it has to drop all of its voltage before it gets back to the battery. So in a series circuit, it doesn't have an option. Just ignore my voltmeter up there. All of the current has to flow through all of the R's because it's the only path. But in parallel, it has choices. When it gets to this junction, some of it can go through R1. Some of it can keep going. When it gets to this junction, the stuff that kept going now has another option. Some of it can flow through R2. Some of it can keep going. And when it does, it goes through R3, comes back together here, it all comes back together here, and the total ends up back at the battery. So in parallel, I total is equal to I1 plus I2 plus I3. But the voltages actually add up. Here, if there's like 120 volts that add up in parallel. 120 volts that are series. At 120 volts leave the power supply in series. Some of it, V1, it gets dropped in R1. Some of it gets dropped at R2. And the rest of it gets dropped at R3. In series, V total has to equal V1 plus V2 plus V3, so that when you get back to the battery, all of the voltage that the electrons are carrying is gone. But in parallel, it's different, because in parallel, electron either does this single loop and goes through R1, in which case it would need to drop all of the voltage that it had, or it would do the middle loop and go through just R2, so it would have to drop all of the voltage that it had there, or it'll do the larger loop and go through R3, so it will have to drop all of the voltage there. So in parallel, V total equals V1 equals V2 equals V3. Why am I saying all that? Because if then you want to place a voltmeter in a circuit, you put it in parallel. Because in parallel, when two things are in parallel, they'll have the same voltage. If you were to put it in series, then it would just take some of the voltage from the other devices. So ammeters always go in series, voltmeters always go in parallel. You think I forgot that I was talking about galvanometers, don't you? But I didn't forget, because I took that little sidetrack because galvanometers are inside of voltmeters and ammeters. And in a second, we're going to look at how the voltmeter and the ammeter is made based on all of this stuff. So I had to review it. But first, what's a galvanometer? It's a tiny coil of wire that's placed in a magnetic field. So imagine I have two poles of a magnet here facing each other. So I take this tiny coil of wire and I put it in here. And on it, I put a needle, a pointer. And then I hook this tiny coil of wire to a power supply of some kind. So now current is going to flow in this wire. And when current flows in this wire, it's going to experience a force from this external magnetic field. And that force is going to make the needle move. And the needle then we can set up on a scale. It's called, we can calibrate it, right? So we put a scale here. 1, 2, 3, 4, 5. I can count. Oh, can I? Okay. The magnetic field is constant. What's going to change is the current flowing. So as the current changes, the bigger the current, the more the needle will move. The smaller the current, the less the needle will move. So we can do what we call calibrate our galvanometer. So now we can take our galvanometer and put it inside a voltmeter or an ammeter and use it to tell us about the current that's flowing through it. Okay, so it's a tiny coil of wire with a needle that's placed inside the poles of a permanent magnet. When there's a current then that flows through the galvanometer, it's going to register a force because it's an external, it's a current carrying wire in a magnetic field. And so it'll cause the needle to turn. Okay? Now, I said it carries really tiny currents. They're usually about 50 microamps. Okay? So that's really tiny. And the resistance inside the galvanometer is usually about 1,000 ohms. Has to be a big resistance so the current will be tiny. So we're going to make an ammeter and a voltmeter out of it. Okay, now to make an ammeter, you place the galvanometer in parallel with a tiny resistor. So I have a tiny resistor, R, and I'm going to put my galvanometer in parallel with it. Why? Because if I have a small resistor and I put the galvanometer in parallel with it, when the current gets to this spot, most of it will go through the small resistor because it always takes the path of least resistance. And only a tiny little fraction will go through the galvanometer because it has a big resistance. And why is that important? Because then I'm going to take this ammeter and I'm going to place it in series with my resistors, and I'm going to get basically the current that's, because remember in series the I's are equal. So most of the current that's flowing through those resistors is going to go through this big resistor here and this small resistor here, and very little of it will go through the galvanometer. So I can get an accurate reading of what this current is. This tiny resistor is called the shunt resistor. It's kind of like the runt. Okay, so a galvanometer inside an ammeter is placed in parallel with the resistor so that then you can place your ammeter in series with whatever you're measuring. That should totally confuse you. Voltmeter is just the opposite. A voltmeter you are going to place in series with a really large resistor. Okay, so here's my galvanometer. So inside my voltmeter, I place it in series with a really large resistor that I'm then going to hook in parallel with whatever I'm measuring. If this resistor is really large, then very little current will go up here, only a small fraction. Most of it will go through here, so the regular circuit, so it won't affect the reading in the galvanometer, or in the circuit. and then I can get an accurate reading